So in part A of the question, we showed that sine A plus B plus sine A minus B is equal to 2 sine A cos B. And we need to deduce that sine P plus sine Q is equal to 2 sine P plus Q over 2 cos P minus Q over 2. So the key here is comparing these and writing down what's the same. So if the left-hand side here is going to be the same as the left-hand side here, then P must be equal to A minus B. A plus B. These must be the same. And also these must be the same. Q must be equal to A minus B. So I'm just looking at the left-hand side. This must be the same as this. This must be the same as this. Looking at the right-hand side, I've got an A by itself here and a B by itself here. So I'd like to be able to say A equals something to replace this and B equals something to replace this. So basically I just need to show that A is going to be the same as this and B is going to be the same as this. I can do that simultaneously from these equations because we're used to solving equations like this from GCSE. If I add these two equations together, the b's would be eliminated. So I'll do that first. Let's add these equations. So on the left-hand side, I've got P plus Q. And on the right-hand side, I've got A plus A, which is 2A. And the b's have been eliminated. B plus minus B is 0. I can now divide both sides by 2. So P plus Q over 2 is A. So I've been able to show here that A is the same thing as P plus Q over 2. That's what we wanted to show. Now to look at the B. Well, in order to eliminate, get the B by itself, I want to eliminate the A. So let me just rewrite these equations very quickly, just so I can show my working separately. If I take these equations away from each other, on the left-hand side, I'll get P minus Q. On the right-hand side, I've got A minus A, which is 0. And then I've got B minus negative B, which is B plus B, which is 2B. I can then divide both sides by 2. So I've got P minus Q over 2 is equal to B, which is again what I wanted to show. So what I've done here is I looked at the left-hand side. I said that P is going to equal this, Q is going to equal this, and then by doing that, I've done a little bit of maths to show then that A would then have to equal P plus Q over 2, and B would have to equal P minus Q over 2. And there we go, we finished that question. We've shown that if this is true, then this must be true as well. So that was part B of this question. Part C of the question said we wanted to show, use our results here to show that 2 sine 7 theta cos 2 theta, and we wanted to be able to write this as the sum of two sines. So I'm using my results, and I want to be able to write this as sine something plus sine something else, the sum of two sines. So let's compare this to what we had in part A. So in part A, let me rewrite the right-hand side of part A, which was 2 sine A cos B is equal to sine A plus B plus sine A minus B. That was the result from part A. So let's use this result to help us to rewrite this. So we can see clearly that A is 7 theta, B is 2 theta. So if we substitute those into the result of part A, we will get sine. So A was 7 theta, B is 2 theta, A is 7 theta, B is 2 theta, and we can clearly simplify that to be sine 9 theta, 7 theta plus 2 theta is 9 theta, plus sine 5 theta. 7 theta minus 2 theta is 5 theta. So we've been able to express the product of sine and cos as the sum of two sines, like that. Then for part D of this question, we were asked to use the result in part B to solve this equation. Sine 3 theta plus sine theta is equal to 0. So using the result from part B, so using this result here, so first thing I'm going to do, I'm going to rewrite this result underneath here. So sine P plus sine Q, that's a Q there, not a theta, is equal to 2 sine P plus Q over 2 cos P minus Q over 2. Right, so just comparing this result with the equation that I've got here, I can see that P is equal to 3 theta, and I can see that Q is equal to theta. So I can replace the P and the Q here with 3 theta and theta. So that would leave me with 2 sine 3 theta plus theta over 2. So this is me replacing the P and the Q with 3 theta and theta times cos 3 theta minus theta over 2. Again, this is me replacing the P and the Q with 3 theta and theta. So this is me using the result from part A to rewrite the left-hand side in this form. And that's got to equal 0 from here. So I've rewritten the left-hand side using this rule, made it equal to 0. I can now simplify this, so I've got 2 sine, well 3 theta plus theta is 4 theta, divided by 2 is 2 theta. 3 theta minus theta is 2 theta, divided by 2 is theta, like that. I could divide both sides by 2, so sine 2 theta cos theta equals 0. And here I've got the product of two trigonometric functions. So I can say, if it equals 0, I can say that either one of these could be 0. So sine 2 theta could equal 0, or cos theta could equal 0. And now I can solve these two equations separately, just like we would have done in year 12. So that was part D of that question. We'll now move on to part E. Part E said to prove that sine 7 theta plus sine theta over sine 5 theta plus sine 3 theta. We want to show that that's the same thing as cos 3 theta over cos theta. Now obviously this is part E of the question. It's following on from these same rules we've been using before. Notice here we've got the sum of two sines. So I'm going to be using this result here to help me. So let me write this out again. So the sine P plus sine Q, the sum of two sines, is equal to 2 sine P plus Q over 2 cos P plus Q, P minus Q over 2. So that's just me rewriting the formula for the sum of two sines. And I'm going to use this to rewrite the numerator and the denominator. So the numerator, sine 7 theta plus sine theta, will be equal to 2 sine, well that's going to be, so P is 7 theta, Q is theta, so 7 theta plus theta is going to be 8 theta. Actually, let me rewrite. This is a proof question, so I'll write it in full. And I've got the cos 7 theta minus theta over 2. Simplifying that, so 2 sine 8 theta over 2 is 4 theta. 6 theta over 2 is 3 theta. So this is me rewriting the numerator. I'm now going to do the same thing with the denominator. So sine 5 theta plus sine 3 theta equals 2 sine 5 theta plus 3 theta over 2 cos 5 theta minus 3 theta over 2. Again, this is me just using this rule with P being 5 theta, Q being 3 theta. So 5 theta plus 3 theta over 2, 5 theta minus 3 theta over 2. And again, simplifying that, so 5 theta plus 3 theta is 8 theta, over 2 is 4 theta. 5 theta minus 3 theta is 2 theta, divided by 2 is theta. So this is the numerator, this is the denominator, so let's rewrite this as our fraction. I've considered them both separately, I'm now considering them together as was in the original question, the left hand side of the original question. And we can see clearly now, hopefully, the 2's cancel, the sine 4 thetas cancel, and so we just get left with cos 3 theta over cos theta, which was what we needed to prove on the left hand side. So this is the right hand side, it's equivalent to the right hand side. So we finished our proof. There we go. That is how we can answer those types of questions. It's all about constantly referring, constantly coming back and referring to the formulae that we proved in parts A and B.